Hi, everybody. My name is Jessica Blatt, and for the last 3 years, I've managed the technology programs in Amazon in our worldwide sustainability organization that measure our company-wide carbon emissions. Climate change is one of the greatest challenges that faces us as a society, and it's really one that we need to tackle as a society as well. I'm here to talk to you about the work that's been happening at Amazon so that others can learn from what we're doing, and in turn that we can learn from others, since none of us can do this work in isolation. In this session, I'm going to talk to you about what our public commitments are and what we're working to enable with the work of carbon footprinting. I'll discuss what we're measuring and how we're using that to drive change. I'm going to dive into the science and the technical details of what we've built, focusing on how we've leveraged specific AWS services, as well as some of the challenges we faced and where we're headed. In so doing, I'm hoping to provide some consideration for how you might approach your own work of measuring carbon emissions for your own organizations. And while this talk does center around Amazon and what we in particular are doing to measure and manage our own emissions, again, a goal of being here today is to grow a broader dialogue in this space. And I invite you, wherever you're watching from, to be a part of that, especially if you can help us go faster. So let's talk about our commitments. In 2015, as you're no doubt aware, the nations of the world came together to form the Paris Agreement, working towards the goal of keeping global temperature increases within 2 degrees or ideally 1.5 degrees Celsius of pre-industrial levels to avoid the most catastrophic impacts of climate change. In September of 2019, Amazon partnered with Global Optimism to launch the Climate Pledge, which is a commitment to meet the Paris targets of net zero carbon emissions 10 years early, by 2040 instead of by 2050. And since that time, companies around the world have signed on to the pledge, and we're working together to tackle this ambitious goal. The Climate Pledge consists of 3 commitments. The first is to measure and report on our greenhouse gas emissions on a regular basis. Now, there are many greenhouse gases that contribute to climate change. And for simplicity, when I say carbon or decarbonization for the rest of this talk, I'm really referring to carbon dioxide equivalent, which is simply a measure that lets us relate and compare emissions from various greenhouse gases based on their global warming potential. The majority of this talk is going to be focused on this particular commitment of the Climate Pledge, but it acts in aid of the next 2. We need the information to take action, and it's the action that really makes the impact. The second commitment is implementing real decarbonization strategies. The specific strategies that are most impactful for your company, of course, are going to depend on what industry you're in and what your particular hotspots are based on your measured carbon footprint. And finally, the Climate Pledge recognizes that it may be functionally impossible in these timelines to really hit net zero with only operational changes, and it does allow for credible carbon offsets that hit a high quality bar. We're not going to talk a lot about this particular commitment of the Climate Pledge, but suffice it to say, you need to measure your emissions in order to know what remains to offset once you've exhausted all of your decarbonization strategies. The Climate Pledge is a 20-year commitment, and to succeed, we know we need to commit ourselves to some major milestones along the way. Looking at our own carbon hotspots, we've created some additional specific public-facing commitments as we work towards net zero by 2040. In 2019, we announced that we're going to be powered by 100% renewable energy by 2030, and we're actually on path to meet that goal 5 years early, by 2025. We also announced in 2019 Shipment Zero, which is our commitment to have our shipments be net zero carbon, with half of them getting there by 2030. This addresses the emissions of our large delivery logistics network. Think about the milestone goals that you can set in your own organization, based on your industry and your hotspots. Being powered by 100% renewable energy may be a pretty common goal, and of course, if you use AWS for your compute, for that particular portion, you'll get it for free as we hit our targets. So now that we've established where we're heading, let me describe how we've approached our own internal carbon measurement work, how we meet that first Climate Pledge commitment in aid of identifying those decarbonization strategies. So the first thing to address about our approach is it's not just one approach. At Amazon, we don't just move information, we do a lot more than that. Our carbon footprint is as diverse as many countries, and we're many companies in one company. Beyond our AWS business, we sell goods and services from both ourselves and from third parties all over the world, including our own private brands that range from food to apparel to consumer electronics, and frankly, the list is growing and growing. We have everything from movie studios to grocery stores under our umbrella, and all of those are supported by complex supply chains and logistics delivery networks. And of course, we're continuously innovating new businesses and in some cases, acquiring mature existing businesses. You may recall, for example, our acquisition of Whole Foods a few years ago. In carbon footprinting terms, that means we have challenges with the number and the variety of data sets that we have to track, and that we also have to model into emissions. We have scaling complexity across multiple dimensions. And of course, we're challenged to ensure that we always have a complete accounting, no matter how rapidly we're evolving. The reality forces us to be pragmatic in our approach. We can't wait until we have precise, real-time insight into the actual carbon emitted for every single thing that happens at Amazon to take action. We focus instead on where we have the biggest opportunities for change, on having the right resolution of data for the right decision and putting it in front of the right decision maker who can use that data to take clear goals. Those goals may be in the form of direct carbon intensity reduction goals or addressing the levers that drive carbon, such as the amount of electricity consumed in a particular building or the amount of fuel that's consumed in a particular operation. Or addressing higher order questions, such as should we be optimizing for slow delivery or fast delivery if we want to optimize for carbon? So how do we know where to start? It's an iterative process. We knew we needed both a comprehensive top-down view to tell us where our hotspots are, as well as a granular bottoms-up view based on enough detail to inform those real decisions that we need to make. Just as we needed to set bold top-down goals, such as hitting net zero by 2040, and granular bottoms-up goals, such as specific carbon intensity targets, reduction targets within our own operations, or adopting specific low-carbon technologies. The core of our work then has been collecting data and building models and tools, not just to measure our impacts, but to enable teams across Amazon to drive significant improvements in how we operate our business through an environmental lens. Both the comprehensive and the granular views are enabled by the scientific models that we apply. I work closely with our sustainability science team, who supply the modeling and the scientific backing for our footprinting work. We apply an academic method called Environmental Life Cycle Assessment, or LCA. It's an approach that looks at emissions from raw material extraction all the way through to end of life. To address the challenge of the dynamic and complex nature of Amazon's business that I mentioned, we actually start with an estimation model whose completeness that we can ensure because it takes data directly from our financial ledgers, and we translated that into the emissions that are associated with that spend. The approach we use to do that is called Economic Input-Output, or EIO LCA, and it's what's used to estimate the emissions that are associated with countries' economies by translating the dollars spent in a given industrial sector to the emissions that are associated with that spend. It gives us a complete but less actionable view because the estimates go up or down only with our spend, not with our actual operational decisions. However, it does point us at what hotspots might exist across the company. And then we augment that with more precise models based on operational data for particular hotspots, or where we have the greatest levers at our control to make a decision to drive change. We started with transportation, packaging, electricity, and devices. Of course, in your own business, the areas that are top priority for you to get deeper insight into with more precise models will of course depend on your hotspots and what's important to your customers, as well as where you have the greatest levers of control. I'm going to talk through two of these models in more detail to show how we use them to drive insight and to make better decisions. So let's start with our transportation model as an example of our more detailed approach. These days, you don't really need a lot of complicated analysis to tell you that electric vehicles are generally going to have fewer tailpipe emissions than diesel trucks, especially if they're powered by renewable energy. But for our transportation leaders to understand where those kinds of mode shifts should happen and what goals specifically they should be taking, we needed something more. Our transportation model focuses on the critical drivers of carbon: fuel types, vehicle types, and routes. It's actually relatively straightforward to take an amount of fuel that's burned and translate it directly into its associated carbon emissions, if you know what kind of fuel it was. Where we may not have the actual precise fuel consumption, maybe due to a lack of instrumentation or because it's happened with a third party and we just don't have access to that kind of information, our model can also take in information about the route and about the vehicle and apply assumptions about the fuel efficiency. In all cases, of course, factoring in the emissions that are associated with producing the vehicle itself. This approach lets us analyze our actual operations and make informed decisions about alternative fuels and other levers that we can pull in aid of sustainability. I encourage you, as you assess your own business and think about the actual inputs that you need to measure change, also consider that if you don't have the exact information that you need, what is the information you can get right now to start making directionally correct decisions while you improve your data flows in the background. This model, this transportation model, using the best data that we have available at whatever resolution it might be, paired with the operational shipment data that we have, actually gives us the basis to track emissions of our packages moving through our delivery network from a fulfillment center to a customer's front door. Teams can use a normalized metric of CO2e per unit per kilometer to help identify particular areas that are carbon hotspots to prioritize. For instance, although airplanes actually carry a relatively small percent of packages, they're major carbon hotspots. The ability to measure our network performance at a granular and not just an aggregate level unlocks the ability for our teams to independently take goals and innovate on carbon across our logistics network. So let's look at another example of how we think about modeling to identify specific levers for change. We built a model that can drill down into our consumer devices, such as the Echo Dot, to find the hotspots that are within the device itself. We look again across the full life cycle of that product, from manufacturing to transport to use to end of life, to see where the emissions are actually coming from. This approach let our devices and services team understand which components are driving the most embedded carbon and therefore prioritize their work with their suppliers. It also lets us understand that on average, more than half of the total carbon footprint from our devices came from when the devices were in use. And with that insight, we recently added a low power mode feature to new Echoes and Fire TVs to reduce their lifetime energy consumption. And also in September, we announced that Amazon is now the first consumer electronics company committed to addressing the use phase emissions of our devices through renewable energy investments, building new wind and solar farms to produce clean energy equivalent to the electricity that's used by every customer's Echo. And we have a bold goal to expand that to all Amazon devices. So now that we've talked about the scientific basis, let's turn to how that translates into software. Conceptually, our system looks like this. We have an evolving inventory of carbon-emitting activities and a growing set of emissions models that we can apply to those activities to produce the outputs that are meaningful to address change in our business. But as you can tell, we effectively built a data pipeline that takes different kinds of activity and turns it into carbon emission metrics. But as with any system, the biggest challenge we face is the data. Not only do we have to make sure that we have all the data to represent all of that complexity that we talked about before of potential carbon emitting activities, when we have those data sets in hand, it's often noisy and sometimes parts of it are missing. It will come in late and it will be incomplete. And of course, sometimes the attributes that we need in order to really accurately measure our emissions and how they're changing just aren't being measured, or maybe they're being measured but not within our operational boundaries. All of this means we've had to be flexible in our approach. We make the best decisions that we can with the best data that we have available. And also, we've instrumented our system to see where do we need to get insight, where do we need to prioritize getting more insight to prioritize plugging gaps or increasing our quality to make better decisions. We address the scaling challenge of one team, which is my team, keeping track of and understanding all of the data across all of Amazon by instead enabling teams that own their operations to also own the responsibility for completely and accurately representing that activity into our systems. We use what we call standard data contracts to scale and also to ensure compliance with international standards and protocols. The contracts are flexible by design. As we noted, one of the challenges is that the perfect data often doesn't exist. We instead provide options for what to vend, and we ask for the highest resolution possible. So with that previous example, if you can, give us the actual gas you consumed. If you can't, tell us how far you drove and whatever unit of measure you measure that in, and in what kind of vehicle. And we'll just do all the unit conversions, and we'll make assumptions about your fuel efficiency, ideally informed by our own operations. It's not just an approach that lets us get actionable insight right now. It also drives a flywheel. We're seeing improvements already in the quality and resolution of data that's available as our operations team roll out improvements in instrumentation that they need to get more accurate data and also take credit for the real change that they're driving. The data exchange model is just an instantiation of our broader approach to sustainability. We recognize that sustainability must be embedded in the operations. It cannot be the purview of just one sustainability team. Teams across the company must take goals and take actions to achieve those goals, including leveraging our system to understand the carbon impacts of their decisions. So let's get into how this really works under the covers. We built our system natively in AWS from the start, as a Spark application running on ad hoc EC2 instances and more recently on EMR. We had to build a system that processes granular data at Amazon scale to support both team-level goal tracking and company-wide views. Teams that own their operations vend data into our Carbon accounting system, we carbonate it, and vend it back using Amazon's big data tools, in this case, Amazon's internal data lake. So, for example, those transportation teams that want to know how their EV deployments are impacting their carbon intensity vend their data into our system. We apply the transportation model to measure the emissions based on the data that they can provide. We vend it back to them, the carbonated data back to them, and then we use that data to analyze progress on our company-wide goals, including shipment zero, as well as our overall goal for net zero by 2040. We can also then analyze drivers of carbon across our transportation network. It's a win-win because we're using the same action of gathering data for our climate pledge obligations for public reporting and company-wide tracking as we're using to give the boots-on-the-ground teams the information that they need to get insight into their operations. And having teams take goals and track progress within this system also, as I mentioned, incentivizes a continuously improving data flow for better tracking and better decision-making to drive further innovation. It also means we all have a consistent view of where we are, whether we're looking at the big picture or the granular details. We leverage CloudFormation and CDK to manage all of our infrastructure. And one advantage that we found of doing that is our ability to reuse the underlying constructs for similar interaction patterns, such as you can see here, ingesting data securely in S3 and then triggering downstream processing when we receive new data. It's a very common interaction pattern for our team. We've been able to use these patterns with little effort in other systems to support different use cases and different business logic by effectively using CDK building blocks. So let's zoom into our data ingestion, that left part of the flow. We use standard tools within Amazon to source data from teams all over the company, and we use S3 as our data storage and management solution. In this example, partners such as our last mile operations team unload data directly from their Redshift clusters into our ingestion S3 bucket. It lets us largely avoid scaling concerns even when we're processing at Amazon scale. We leverage built-in support such as IAM and KMS server-side encryption to ensure that only authorized users can access only what's relevant to them across our workflow. That means that we have a secure solution that's efficient to expand as Amazon grows and as we need to onboard new datasets. Put all of that together with CDK, and we can create secure ingestion channels for differing sources with relatively minimal manual overhead by the team. We leverage S3 events to trigger lambdas for processing data as we receive it, and we keep enough information about the input data in our data lake so we can trace the carbon emissions back to the actual activity that drove it. Overall, this framework also lets us apply automated quality checks on the data as it's coming in to address some of the data quality challenges that I've already discussed. We follow a trust but verify model when teams provide us with a complete accounting of their operations. So let's zoom in on the middle part of that workflow in orchestration and computation. We orchestrate our workflows with step functions, and we kick off compute by spinning up an EMR cluster, which we then terminate when it's not in use. With this approach, we use only the processing power that's needed, keeping the footprint of footprinting low, and with no human involvement to carbonate a given dataset. This focus on using the absolute minimum that's needed is not just environmental, it's also frugal. We can compute the entire footprint of Amazon for about the cost of lunch here in Seattle. And an interesting functional and technical challenge that we've seen in this space is the importance of tracking which specific inputs were used for a given computation and output. Emission factors change over time. Activity data changes over time. And as those improvements happen, we need to allow ourselves to take advantage of the better data and better insight while also still being able to prove to ourselves, our internal customers, and our external assurers how we reached the conclusions that we did at the time that we reached them. We address this partly with the metadata that we store with a given record, but also by using a manifest to inform the system and to record which particular inputs were part of this particular execution when we start to bring all these datasets together. In general, using S3 as our storage layer has helped us avoid the overhead associated with database administration. We've also been able to take advantage of some built-in features, such as S3 object locking, to create durable archives of the footprint. So we can always know exactly what went in, for example, to a particularly publicly disclosed version. This layer, again, reads from and feeds into that internal data lake, which I would call our carbonated data lake at this point, to feed our reporting and analytics to drive change. As I mentioned, we built it natively from the start, And the event-driven approach basically means that we have 100% availability without any of the concerns of maintaining hardware. And as we mentioned, our use of CDK means that all the infrastructure is managed in code without additional manual overhead. The result of all of this is that our operational burden is extremely low, so we can focus our efforts on adding new features to drive carbon down. We've deliberately used very standard AWS technology so that we can focus our differentiated efforts on measuring carbon impacts and enabling decision-making, not on maintaining servers. An interesting lesson learned here was that the importance of making the calculation logic easy and accessible anywhere the decisions are being made. Our emissions models that are evoked as part of this workflow need to be just as easily invocable when people are running experiments or doing forecasting or any number of other use cases where people need to account for the carbon implications of their decisions. And finally, we surface the outputs. We end up with both the granular data as well as the aggregated rollups in our data lake, meaning we can identify hotspots and, most importantly, drill down to get more insight into what's driving them, as well as where, again, we may need more data to actually measure our change. We output to S3 in the open source Parquet format, which enforces schemas, something that we found absolutely invaluable in this dynamic data world. We use glue crawlers to make it easy for us to make our data immediately deep diveable for those IAM authorized users to query via tools like Athena. And also having built-in QuickSight integration means that we can build out dashboards on top of our data sets for analytics. Both Athena and QuickSight then give us visibility for company-wide goal setting and tracking and analysis. We also vend slices of our data to internal tools, such as our Amazon Data Catalog, for broader consumption of specific data sets that teams can use within their own reporting environments. For example, by embedding carbon metrics directly into their business metrics reviews alongside their other key performance indicators. Again, we want the data to be available where it's going to drive the right decisions. So now we've seen in detail how our system ingests, processes, and surfaces data. And one output of that is our corporate carbon footprint. For example, we calculated for 2019 that our company-wide emissions were 51.1 million metric tons of carbon. It's a really useful number to let us track aggregate process, but it's basically a byproduct. It's an aggregation of broader estimations that we've put together to help us identify hotspots, as well as those many granular calculations that we use to enable leaders to drive change. Our ability to measure our footprint is a commitment of the climate pledge, but one that's primarily useful for the decisions that we can drive towards hitting net zero carbon as a result. Recall, the end goal here is to enable real decarbonization strategies and hit net zero carbon. We've also learned other things beyond that aggregate 51.1 number. I gave a few examples earlier of the kinds of insights that our models can inform, such as where there are particular hotspots within the footprint, within our transportation network, or even within specific products. But taking this approach has also let us come to conclusions that were a little surprising. For example, we built a specific model for packaging because we knew it was an area that we had a lot of control over and because it's top of mind for our customers. But the data tells us packaging just isn't that big a part of our carbon footprint. And as a result, to make the biggest impact both on carbon and for customer experience, we focus on dematerializing and right-sizing packaging. The transportation emissions are a much more substantial piece of the pie. I also mentioned earlier that we'd be able to inform higher level decisions, like whether to optimize for slow or fast delivery from a carbon standpoint. Interestingly, our lowest carbon shipment option is generally speaking same day. And that may seem counterintuitive at first, but it actually makes sense when you think about it. The same day package is really unlikely to go on a plane. That lets us see that inventory placement algorithms are actually one of the most powerful levers in addressing carbon that we have, since we can use slower, low carbon methods to put the inventory in the right place and then still delight customers with fast delivery, all with lower and not higher emissions. So we've talked about what we've built and how we've approached the problem, and a few things that we've learned along the way. But make no mistake, it's day one, and there's plenty of work we still have ahead of us. Among those challenges that we still have to address include continuously increasing the resolution of our data and the breadth of our decision-making tools, again with the goal of empowering more decisions where they happen to factor in carbon. And a particular challenge that I've mentioned before is getting enough information about what's happening upstream and downstream of our own operations, since we have limited visibility into what happens outside of our direct control. I'll speak more about this in a second. An area that I'm personally excited to see evolve is our continued innovation on behalf of customers, not just to reduce our carbon footprint, but theirs as well. As not only an expert in Amazon's carbon footprint, but also a longtime Amazon customer with a Kindle, a Fire TV, a Fire tablet, and maybe more than one Echo in my house, just as an example, I was personally thrilled to see the innovation that I mentioned from our devices team in addressing the energy emissions from customers' use of Amazon devices. I encourage all of you, think about what creative solutions you can bring to bear on behalf of your customers to address the carbon impacts of their use of your products. One of the greatest challenges is also the greatest opportunity in this space. And if you get one thing from this talk, let it be that we must act, and that must be together. This is even true in a measurement sense. We can make assumptions and we can apply models, but we cannot know for sure if we're getting to zero unless we know our partners are doing so as well. This makes intuitive sense if you think about all of the complex supply chains that go into running an institution. Amazon's ambitious net zero goal includes these indirect emissions in the value chain, both upstream and downstream of our actual operations. In concrete terms, that means measuring and making carbon-reducing decisions on everything from the construction of our new office buildings and data centers by contractors that we work with, to third-party logistics providers that transport both corporate and consumer goods into and out of our network, to the extracting and refining of raw materials that go into our devices, just to name a few examples. We encourage everyone to take this wide net approach in considering the scope of their emissions and their goals, and that means that we all need to partner together to reach net zero and accurately track our progress towards it. The need to partner extends well beyond measurement and our day-to-day operations. We need strong partnerships across industry, academia, and governments to enable the creation and mass adoption of technologies needed to achieve a net zero vision. At Amazon, we're demonstrating this demand, for example, with the largest order of electric vehicles in history in our work with Rivian, and we are also now the largest corporate purchaser of renewable energy in the world. We're also making direct investments via the Right Now Climate Fund to stimulate needed technologies. As you consider your own carbon footprint, think not just about the levers that you directly control, but where you also have the opportunity to work with your partners and join other institutions, join the Climate Pledge, join other commitments to drive broader change. I look forward to seeing what we can do together. Thank you for your time.